I thought it might be helpful for you to hear me explain some of the problems on the worksheet writing equations from graphs. So let's look at our first problem here. When we're looking at this graph here, we notice that it has a vertical asymptote at x equals -4 and a horizontal asymptote at y equals 2. Now think about when you graph an equation, the thing I asked you to do first was to find the vertical asymptote. That's because that's the easiest thing to find. When I see that there's a vertical asymptote at x equals -4, I know that -4 makes the denominator equal to 0, so the denominator must have an x plus 4 in it. So I already know it, so that I know what the denominator is. Then I ask you to find x and y intercepts. I can't really see what the y-intercept is here. I know it's between 2 and 3, but I don't know exactly what it is. But the x-intercept is 5, 0. The x-intercept is a number that makes the numerator equal to 0. So that means that x minus 5 must be in the numerator, so that when I put 5 in for x, I get 0 over 9 here, which would be 0. Okay, so that means that's an x-intercept. So there might be something else in the numerator too, so that's why I put a question mark, but I know that x minus 5 has to be there. Okay, now I'm going to look at my horizontal asymptote. My horizontal asymptote is at 2, and we found out that if we have a non-zero horizontal asymptote, remember 3 different cases, either a horizontal asymptote at 0, a horizontal asymptote not at 0, or we have a non-horizontal asymptote, like a slanted asymptote. But the horizontal asymptote would occur when the numerator and the denominator have the same degree but different coefficients. So if I had just x over x, my horizontal asymptote would be at 1. It's at 2, so it must be 2. There must be a 2 in the numerator. If I multiplied this out, it would be 2x minus 10 over x plus 4. The 2x over the x would give me the horizontal asymptote at 2. The -4 would give me my vertical asymptote. 5 makes the numerator equal to 0, so that gives me my x-intercept. And then the y-intercept, if I put 0 in for x, I just check that here. That would be -10 over 4, or -5 halves. That's -2.5, and that's exactly what it looks like on the graph. Now that's one method to do this. The other method, which some of you might find more comfortable, easier, would be to say, okay, I see these crossed asymptotes. This reminds me of the graph y equals 1 over x. Okay, f of x equals 1 over x. And things have just been shifted to the left and up, and also maybe flipped upside down. Okay, so if I see that it's been shifted left 4 and up 2, that means there's an x plus 4 in the denominator, and there's a plus 2 outside of the function here. And I just need to figure out what that top number is. I know a point on the graph, 5, 0, so to find the number in the numerator, I just substitute 5, 0 in for x and y, and then solve it. And when I solve it, I find out that a is -18. So the equation f of x equals -18 over x plus 4 plus 2 is the same equation. It's equivalent to 2x minus 10 over x plus 4. If I multiplied 2 times x plus 4 over x plus 4, I would get 2x plus 8. When I add 2x plus 8 to the -18, I would get the 2x minus 10, and then my denominator would be x plus 4. So they're just equivalent.